Welcome to Perpendicular and Angle Bisectors. Today's objective is to prove and apply theorems about perpendicular bisectors and prove and apply theorems about angle bisectors. Let's look at two examples of perpendicular bisectors and see if we can draw some conclusions from them. So, if I have a line segment with points A and B, and then I have a perpendicular bisector, what I know is these two segments are congruent and the distance from a point on the perpendicular bisector to these points is congruent as well. So I know that segment AY is congruent to segment YB. Since this was a perpendicular bisector, I also know that AX is congruent to XB. It's perpendicular as well, so I can also say that XY is perpendicular with AB. And this theorem is known as the perpendicular bisector theorem. So the perpendicular bisector theorem says if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. And we also have the converse of the perpendicular bisector theorem as well. So let's discuss that one. So the converse of, I'm going to abbreviate here just for space, the perpendicular bisector theorem. So if you start off with knowing that we have a point that is equidistant from 2 points, what you know is that they must lie on the perpendicular bisector. So the first thing you know is that they're equidistant, and then you know that's on the perpendicular bisector. So here, the first thing we know is that it's on the perpendicular bisector. For this one, all we know is that they're equidistant first. So if we know that, let's call this point X, if we know that XA is congruent to XB, then your conclusion is that, let's call this point Y right here, XY is perpendicular to AB. And those are the perpendicular bisector theorems and the converse of the perpendicular bisector theorem. Let's apply these theorems now. So if we look at example A, we see that we have line WZ, which is a perpendicular bisector of XY. It's split these into two congruent segments. So if this is 7.3, then YW has to be 7.3. For B, it's asking us to find the length of this entire segment BC. Since these are the same, we know that this must be a perpendicular bisector. So this is 16, that means this has to be 16. So that means BC has to be 32. Now for this last one we have to do a little bit of algebra, but since SR is a perpendicular bisector of PQ, we know that these segments have to be congruent. So 2n plus 9 has to equal 7/9 minus 18. Then we do a little algebra, and we know that 5n equals 27. Divide both sides by 5, and n equals 5.4. So you're looking to see either if these sides are the same or if these segments are congruent. And then you can make conclusions based off of that. Let's look at another example of perpendicular bisectors. So for example A, we're given that line L is a perpendicular bisector of DE and that EG is 14.6. So if we know that this is 14.6 and this is the perpendicular bisector, we know that this side is 14.6 as well. So we know that segment DG is 14.6. For part B, we're given that DE is 20.8. Now we know that DG is going to be 36.4 and EG is 36.4. It's asking us to find the length of EF. Well, if these two segments are congruent, then this has to be a perpendicular bisector. And if these two are both the same, then we basically have to just take the entire length of DE and divide it by 2. And we're left with 10.4. So that is the length of EF. Let's discuss the angle bisector theorem and its converse. So we're going to be looking at the relationship between an angle bisector and the distance between the sides from the point. So if we have an angle bisector here as point C, we know that it splits these two angles, but we also know now is that the length of segment AC is congruent to the length of segment CB. So if you have a point that's on an angle bisector, the length from the angle from that point to the sides of the angle is congruent. So for the converse of that, if we have a point on some type of ray that's coming out of the angle and these two sides are congruent, what we know is that it's on the angle bisector. So this is the angle bisector theorem. And we have the converse for the angle bisector. Let's apply the angle bisector theorem to find the measures of length LM and to find the measure of angle ABD. So we know that this ray right here is an angle bisector because angles 1 and angle 2 are congruent. So if they are an angle bisector and these angles are congruent, then we know this length right here has to be congruent to this length. So we say LM is congruent to JM, which is equal to 12.8. So for the next one, we're trying to find the measure of angle ABD, given that the measure of angle ABC is 112. So we know this entire angle is 112 degrees. And since these two segments are congruent, these angles have to be congruent as well. So to find the measure of angle ABD, which is this angle right here, all we do is divide 112 by 2. And we get 56 degrees. So right here for this problem we applied the angle bisector theorem, and in this one we applied the converse. Let's apply the angle bisector for these two problems as well. So we're given that ray YW bisects angle XYZ and that WZ equals 3.05. Let's find the length of WX. So we're trying to find is this side right here, but we know that YW bisects this angle. So both of these angles here are congruent. Now, if WZ is 3.05, we know that WX has to equal 3.05 as well. That was part A. Now for part B, we're given different information. So now we're given that the measure of angle WYZ is equal to 63 degrees, and that XW and ZW are both 5.7. So ZW is 5.7 and XW is 5.7. Now the angle WYZ, which is this angle right here, is 63 degrees. But since we know that these two sides are congruent, that means that this is an angle bisector. So if this is 63 degrees, then this angle has to be 63 degrees as well. It's asking us to find the measure of XYZ, which is the entire angle. So all we have to do is just add up 63 and 63. And we get 63. Hold on one second. 63 plus 63 is 126. Now let's use our knowledge of perpendicular bisectors to write an equation in point-slope form for the perpendicular bisector of the segment with endpoints -1, 6 and 3, 4. So let's draw these points on this graph and see what we have to do. So the first point is -1 up 6. 1, 2, 3, 4, 5, 6. So point A is right up here. Point B is at 3, 4. 1, 2, 3, 1, 2, 3, 4. So here's our segment. So what we have to do is write an equation for a line that's the perpendicular bisector of the segment. Since it's the bisector, we know we have to find out what the midpoint of this segment is, because we have to split this segment into two halves. So the first thing we want to do is find the midpoint. So we know the midpoint is just the average of the x values and the average of the y values. So we're taking both x values, adding them together, dividing by 2. Taking both y values, adding them together, and dividing by 2. So for x values we have -1 plus 3 divided by 2, and then we have 6 plus 4 divided by 2. So our midpoint is 1, 5. So we found the midpoint. So now we need to find is the slope of AB. So we have to find the slope of AB because once we get that, we will know what the perpendicular segment is, because that will be the negative reciprocal of the slope. So to find the slope, we have to do the change in y over the change in x. So y would be 6 minus 4 over -1 minus 3. So we have 2 over -4. So the slope of this line right here is -1/2. Now we have to remember we want a perpendicular bisector. Now we know the slope of a line that's perpendicular to another one is the negative reciprocal. So the slope of the perpendicular bisector is going to be the negative reciprocal of -1/2. So that's just going to be 2. So I have a point and I have a slope. I'm writing this in point-slope form. So in a point-slope form is y minus y1 equals m times x minus x1. So my y variable, I leave it as is. My y value of 1 is 5, so y minus 5. My slope is 2. My x variable, I leave that as is, and then I have my second x value. And this is the equation for the perpendicular bisector of the segment AB. Alright, let's practice one more. So here we're doing the same thing. We're writing this in point slope form. And we're writing a perpendicular bisector of this segment. So first thing I want to do is find the midpoint. And I take both of my x values, so 5 plus 1 divided by 2, and both of my y values, 2 minus 4, and divide them by 2. So I have 6 over 2, which is 3. And I have negative 2 over 2, which is negative 1. So that's my midpoint. Now I need to find the slope of PQ. So that's the change in y over the change in x. So we have 2 minus a minus 4 over 5 minus 1. That becomes 6 over 4, which is 3 over 2. So that means the slope of the perpendicular bisector is going to equal negative 2 over 3. So I have my point and I have my slope. So my equation is based off of the y equals y1, sorry, y minus y1 equals m times x minus 1. So my y value is negative 1, my slope is negative 2 over 3, and I have x minus 3. And that's our equation for the perpendicular bisector of this segment. That's the end of the video. Once again, thank you and take care.